Okay, before we go further in our algebra, I want to just highlight one thing. One issue that a lot of students have, I've noticed, is that they don't understand this very fundamental idea, this golden rule of maintaining equality. And if you want to progress even an inch in algebra, you're going to have to understand this really, really well. You're going to have to understand what maintaining equality means, because if you don't, it's impossible to go any further. So what is maintaining equality? Maintaining equality is this idea of what you do to one side, you must do to the other side. So for example, if I were to add a 1 to the left-hand side, I have to do that same thing to the other side. So if I want to add a 1 to the left-hand side, I have to add a 1 to the right-hand side. Otherwise, this equality symbol is no longer true. So what do I mean by that? Let's say you were just to add a 1 to the other side, and I'm just going to write the equal sign underneath and just evaluate this. So I haven't changed anything, I'm just evaluating it. Then if we do that, we see that this is the same thing as saying 3 is equals to 2, which is not true. So in the beginning we had 2 is equals to 2, which was true. I added a 1 to the left-hand side, and now I have 3 is equals to 2, which is not true. So we've not maintained equality. This is no longer the same thing as saying 3 is equals to 2, because it's not. The only way to maintain equality is, since we've added a 1 to the left-hand side, we have to add a 1 to the right-hand side. So once we simplify, we get 2 plus 1 is equals to 3. So 3 is equal to 3. Let's do another example. So remember, what I do to one side, anything I do to one side, if I want the equality symbol to still be true, I have to do that exact same thing to the other side. So anytime you find yourself doing anything on one side in algebra, you have to do that same thing on the other side if you have an equal sign. So for example, let's say I multiplied the right-hand side by 3. I would have to do that same thing to the other side. So I would have to multiply by 3 on the left-hand side because I multiplied 3 on the right-hand side. Simplifying this, we see that 6 is equals to 6. So we've maintained equality. 6 is equals to 6. So the golden rule, nail this in your head, is what you do to one side, you have to do to the other side. You have to, otherwise this will no longer be true. Now, let me give you just a short example of where this appears in algebra. Let's do a very, very simple algebraic expression. So let's do So we have x plus 1 is equals to 3. Now I'm just going to, we're going to come back to this, but let's just quickly just show you two things. We know two important facts that will be used for this. So these two important facts are, if you were to subtract any number by its opposite, that is always equals to 0. So that's 4 minus 4 is equals to 0. If I were to put, let's say, 3 minus 3, that's always equals to 0. Any number minus its opposite will always be 0. I think that's pretty clear. So that's what the first part says. We're going to use this first rule here soon. The second rule we'll use, or fact that we'll use again here, is this idea of any number added to 0 is that same number. So 3 plus 0 is equals to 3. 1 plus 0 is equals to 1. Because the 0 does not change that number. It doesn't add or subtract or anything to the original number we're adding it to, right? That's pretty simple too. So we're going to use these two really simple ideas to evaluate this. So let's bring all the things we learned. So we learned about maintaining equality this video, and we're going to use these two properties. So if this is not too clear what I'm doing, that's fine, because once you do more and more examples, you'll get it and it'll become easy. And then you'll look back and go, oh, it's so obvious what he's doing. So I want to try to get x all by itself to see what that's equal to. So we're saying x is some number, we don't know what x is. We're just going to put x and then we're going to find out what that's equal to. So let's try to get rid of the 1. So what do we know? We know if we add the opposite of a number, we get 0, right? So let's subtract 1 from both sides. Because I subtracted 1 from this side, I must do that same thing to the other side. Maintaining equality. What you do to one side, you have to do to the other side. Let's evaluate this. So we know that 3 minus 1 is 2. And we know that this is x. And we use property 1. Any number subtract its opposite is equal to 0. So 1 minus 1 is 0. So now we have x plus 0 is equals to 2. Now we use property 2. Any number plus 0 is equals to that same number. So we're saying that x is a number which we don't know. So we can treat x as a number. So x plus 0 is equals to x. And that's the same thing as saying 2. So we found out that x is equals to 2. So this expression, we did some algebra here, and we found out that x is equals to 2. And you can see how important the maintaining equality is at each step. So if we did not subtract a 1 from both sides, this would no longer be true. So we're going to use this idea of maintaining equality a lot in algebra, and I'll start very slow and I'll progressively get more and more and more complex. So in the next couple of videos, we'll do some simple examples of addition and subtraction, and then in another video we'll do an example regarding multiplication division, and then after that we'll do an example of subtraction, addition, multiplication, and division with algebra. We'll progressively get more complicated.